Hello, and welcome back to another episode of Space Engineers. I'm the Almechanist, and in today's episode I plan to program the drill setup we have been building in the last few episodes. So over the past few episodes we've been building this drill setup, and I'm quite pleased with it so far. However, it very quickly fills up on stone, so we need to get it automated so that we no longer waste any of the precious stone that we mine. There's a few things I want to set up before that, however. For instance, the programmable block. I want to replace these conveyors with cargo containers because there's no reason not to use that space. However, will this drop into the void if we don't connect it? So let's have a quick experiment. Whoa, boy, it's dark down there. There we go. So let's get the hood back. If we get the advanced rotor, yes, it can be attached on the side. So we've got anchor points on the side. Always nice to check that before you grind out something support. So all we need is a block here, a block here, because we discovered the other day there is attachment points on the side of connector, for instance this side, but not necessarily this side. And there we've got it connected up. We may also want to put one right there, and then we can now grind this away. I'm still nervous. Oh, and I'm running out of fuel. So in order not to let this fall into the void, let's fully build them up. I don't intend for them to stay, but I don't want to accidentally grind them away. And now, grindy. There we go! Oh, that looks so precarious. Right, cargo container. Is that 7? A small cargo container. Yeah, that's cargo container number 1. And the other cargo container I wanted was this one. However, in order to get that to work, we have to make sure that we are connected here, yes. But this is the only connection point onto this piston part. So we're going to need to use merge blocks to get this one. And I believe, since we've got a full battery, let's see, it's on auto, that should power this connector here, and we shouldn't fall into the void. Should still be able to grind this away and then merge block this on. So okay. Ooh, that always sets me on edge. 7. So how are you, Mr. Block? Yep. And I don't really need to do this, but it will demonstrate that this is not connected. Tether piston on. Ah, it's just going very slowly, but you can see, yeah, it's no longer attached. So reverse. Right, that should be near enough, yeah. So, mergy again. And we need one going that way and that way. And there we go. There should be one again. So that grid and that grid should be the same grid now. Okay, so that is the 2 cargo containers I wanted to add. That should give us a bit more time while mining, and now we can destroy these. So 2 more things I wanted to do before I get into the programming. Number 1 is that I want to place a programming block on here, obviously. We will need something to program. So programming, there we go. And that, I was wondering where to put this. don't necessarily want to put it in front of any of these because that's a connection point to the conveyor system that I could be potentially disturbing. And this is appearing on its side. Can I not? Oh dear. Looks like I can't do it that way. I could make a miniature floor around here, since this doesn't look like it's going to affect the drilling. So I'll add this on, and we'll use this as the beginning of the floor because I want to use Shaustal's catwalks. I think his name is pronounced like that. So to produce the rest of the flooring area for this. So a small half block like that will be quite good, and I could actually put these on as well if I can get them the right way. There we go. And there we go. We've got a bit of a walking area, and we can place a little computer there. I feel like one side will be for walking around, and the other side I might put some functional stuff. I might even put a refinery, or some of the basic refineries on here to help with the processing, and one basic assembler so that if we have stone and power, we could essentially fill the welder up, which would be good. And what else do I need to do? I just need to get this welded up. And there we go, we have a programmable block on there. Not doing too bad. Ooh. But that's what happens when you ignore that. So, there we have our little platform, and now I wanted to actually add a proper refinery on this building in order to improve the rate at which we can handle stone. Let's see how much we've gotten rid of stone in there. Are we actually getting through it quite well? We're down to our last 5k. And then there's some in a small cargo container, probably on the drilling rig. Yeah. I think it'll still be handy. So, I'm going to put a refinery, a proper refinery, into the base. A refinery. There we go. We don't need the programming block at the minute. And let's... So that's the basic one, and this is the proper one. Onto the menu. Order up all of the components. And what do we need for this? So, what I'm going to do is... Let's place a couple of platforms here. And then we can place the refinery there. But, yeah, if we put it there, it'll be a connector, and it'll be in place of that pipe that was there before. Perfect. And it's huge! Look at that. Absolutely huge. Okay. And I think there is a nice bit of room for the upgrade modules, even with this in the way. I was a bit worried about that. But I think this should do fine. In fact, I know a trick to do this is to actually just put a welder on here. A cheeky welder. Shall we? Twist it around that way. And if we toggle this on, there we go! That will slowly build that. Yeah, it's going to take a while. Since that one basic assembler is just going at it now. And there we have it! Ooh. Thank you, Mr. Welder. And we can grind you away now, as thanks for your service. Right. Another thing that I could do with is the proper assembler. So, where could that go? Could either go in place of a couple of these tubes here, but what do we want? Or it could go up on top of this refiner, and we could actually move the tube to go down, like across and down. I will try that. There we go. We now have a proper assembler and a proper refiner, and we'll add some upgrade modules around these two things. However, this is just temporary for the moment. When this miner has gone down a few levels, as I said in earlier episodes, we will be using the central dugout area as our base, so can't wait for that. We will use this predominantly as display screens, perhaps some sort of elevator down. I don't know how exactly it's all going to work, but we can only experiment. And then we can build some buildings around here that are connected via little pathways and see what hijinks we can get up to. So I think the only thing left is this programmable block. We want to get started on the programming. So what I am going to do is, let's exit, save how we're currently doing, and then we will switch to Visual Studio. So here we have the project wizard, and I'm going to create a new project. This was a little experimental project, and what we're going to do is come in here, make a new, it's in-game script. If you're interested in doing scripting yourselves, I'm considering making a little tutorial series on various aspects of scripting. And I suppose the first one would be getting yourself up and running with Visual Studio and Malware's development kit, MDK, which allows you to quite nicely work with the scripts in a proper development environment. So we'll call our script this, automated mining, and we'll put it in our Space Engineers folder, and let's see. And here we go. We've got our in-game script boilerplate, our little template given to us by the MDK. And this is where I'll probably speed this up and discuss the results when I come back, so that you don't have to watch me experiment and whatnot. Anyway, see you in a little while. Hello, Editor Almechanist here. I'd like to use this portion of the video to discuss a couple of topics. Going forward, I plan to do 2 regular episodes a week, one on the weekend and one midweek. Currently the episodes are getting rather long, and I feel like I could split them into 2 separate episodes. I also plan to produce a set of tutorial videos to help people learn scripting. The tutorial videos will allow the main episodes to concentrate on an overview of the techniques I use to program the in-game scripts, while the tutorials can give a more in-depth look at the processes used during scripting. As for the actual scripting portion of this Let's Play, I did deliberate on whether to include them or not. However, I felt that not including them leaves out a large chunk of the effort that goes into creating the constructions in Space Engineers. To me, programming the scripts in Space Engineers is like building with the blocks. Leaving it out would miss out on a substantial amount of the progress towards the goal. I like Let's Play series in which you feel involved in the journey, where you watch as a creation grows along with the player. So that is the style I wish to use in my own Let's Play. However, showing the programming in real time would be lengthy and reminds me of the problems with puzzle game Let's Plays. Puzzle game Let's Plays can be kind of frustrating to watch. If you spot something the player doesn't, then you just have to wait until they either discover it or another way around it. Programming can follow the same pattern among some of its other problems, and to those not familiar with programming, the language being used, the API, etc., then it can just feel opaque and non-inclusive. So I decided to include it as a time-lapse and explain the overarching ideas that happen in the programming segments as a voiceover. That way I can give a substantial feeling to the programming sections and reduce the frustrating parts where I write and rewrite code as I refactor it. So without further ado, I should probably explain what it is I'm doing here. For this programming session, I had a plan. However, much of the programming is done on the fly. There are many sections which I'm tempted to refactor, but this version of the minor script is supposed to be temporary. I want to rewrite it eventually. There isn't always a temptation to write a perfect first version, but it is often more beneficial to write something that just works and see where the pitfalls lie in a task. Eventually, when I program some interoperable programs, I plan to rewrite this minor to conform with the other programs in my base. So, one of the first things I should discuss is I had a concern that things could go terribly wrong if a portion of this program ran out of order, which is entirely possible when the game is saved and then loaded again. The program will start from the beginning, forgetting all of its state, unless we save it somewhere. To tackle this problem, I have decided to program the script in a particular way. The script is controlled by modes, and these modes are mostly agnostic to what's happened before. They continually apply their logic every time the script is called, and then when certain conditions are met, the script shifts modes. The mode is stored in a quantity called the storage string, which gets saved along with the world when the game is saved. And when the game is next loaded, the script can reinstate the mode and continue operation without trouble. An example of the stateless modes works like this. While in drilling mode, the script will enable all the drills in the drill group, the rotor and the piston. The piston will be set to the desired velocity and it will check two conditions. Condition 1 checks whether any of the drills have filled beyond a certain threshold. If so, the mode will change to retracting. The second condition checks whether the piston has reached its maximum extent. In this case, it will also change its mode to retraction. And here is where I slightly break my stateless design principle. More out of laziness than out of necessity. I store a variable called filled, which indicates which of these conditions was met. If any of the drills were filled, the variable should be true. If the piston reaches its maximum extent, the filled variable should be false. However, this state variable is fine in this case because if the world is saved and reloaded, we can default to the case where the filled variable indicates the drills were filled as a bit of a cheat. So after retraction, it will continue to mine for resources. However, when it finds no resources until fully extended, it will swap over to extending the tether again. So a little bit of a delay, but not too bad, I think. After writing all of this, however, I am beginning to wonder whether I've done all of this as I've said. Maybe I'll have to have a check over that later. In order to map mode names to functionality, I use a dictionary of actions. Dictionaries are mappings of one sort of value to another sort. In this case, I'm mapping a string, a text piece of data, to an action, a portion of runnable code. This may feel weird to anyone from a procedural programming background, as this is closer to what's known as functional programming. Passing functionality around like it is a value is part of the weird and wonderful world of functional programming, and the alternatives are a lot of messy decision branches and whatnot. During the process of writing this script, there were a couple of values I could only guess at. For instance, how fast does the piston need to move while drilling? How fast does the rotor turn? Or how much should we wait for the drills to fill up before stopping the drill operation? Luckily, Space Engineers comes with a helpful set of tools for storing data in strings of text. One is a command line parsing class, and the other is a custom .ini file parser. I use the .ini file parser to store useful default values. This is nicer than hard coding the values into the script, as you can easily change them while in game. The ini file is read from the custom data, and I intended to save it back to the custom data after reading so that the default values would be inserted. However, as you will soon see, I forget to do this and only catch it later in the episode. While programming the inventory management part of this script, I do struggle a little with the API, as you have to deal with strange data types such as the my inventory item and my fixed point. I do eventually come up with something that looks like it will work, but we will have to experiment to see for sure. In order to get the stateless pattern working with the assembler and welder to fill it with the appropriate components, I opted for a fixed value approach. The number of components in the welder, assembler inventory, and assembly queue should always remain constant, or at least above a certain value. This way, if the components end up getting used or stolen by another process, more will be queued up to correct the imbalance. This works even in my stateless paradigm. The function can be called multiple times and the number of components will remain the same until they are used. And then we can exit the state when the welder has enough components. Okay, we're back. And I think that is enough for the first, well actually I think it's a bit too much for the first little portion of programming. I'm going to test this stuff out, see how it goes, and then we can try and implement some of these other functions. So what I've implemented so far is the drilling portion of the code. So we've got, let's see, we've got these modes in which I will be putting the programming block into these modes. They will process, and then one last step I suppose, we need to set the update, so that will continually update every 10 programming block ticks. I'm not sure how long that is, but we'll soon find out. That should be fine anyway. This program could probably even run every 100 ticks. There are a few things which are timed, like current position of the piston, but anyway, getting onto a side point there. We've got mode drilling, which is the slow drill going down, and then when the drills start to fill up, we will move on to the next mode, or if the drill gets to its full extent, or one block, then we will go into retracting mode as well. But this little flag of filled will be important. Mode retracting, we will retract at a higher speed, and then we will connect whenever we can connect, and once we've connected we go into the mode connecting, in which we will try to transfer all the stone and fill the welder with parts, which include, so we've got this transfer stone which simply finds all of the inventories outside of the drilling rig, it will then transfer from all of the cargo containers on the drilling rig into whatever inventories it can find, if it can transfer to them. So it's connected. There we go. That will show you whether you can transfer or not. Hopefully. I haven't tested it yet. That's what the next stage is for. And then after that happens, we go through the welder and make sure that a list of items are supplied to it in the correct amounts. And we also go to the assembler and make sure that it's either processing or already has it in its own internal inventory, a set of items. And then at the bottom here we have these two conditions which will move us on to the next stages, which we haven't completed yet, so we'll have to see how this works. So other than that, let us switch over to the game. Right, so we are back. Let's go and browse our scripts and automated mining. So by deploying it from Visual Studio, here it is. And there we go. Okay, check code. Compilation successful. Okay. Now, what do we do now? We need a button panel, I believe. And that can go right here. That would be a good place. One other thing I wanted to do was place a assembler and a refiner, a basic assembler and a refinery on the back here. Basic refiner there, and 9 there. Let's put it around like that. Should we put it there or there? Let's actually put it there. We can also look in the custom data. So we haven't got anything yet. Do we need to just run it once? Aha! So we've got our first error. Let's do the rest of this building and then we can sort out the error. Right. I've just fixed the one line. I've just checked whether our little parsing function has any work to do. So if we go to edit, browse scripts, this one should be changed, and that's the new line that I've added. So if we're less than 2, it won't run this line. We won't add anything to the results. So check code, compilation successful, okay. And we got another one. So let's see. Piston not found. Tether piston. Fair enough. That's an actual error that I put in myself. And there we go. Okay. So basic assembler. We're going to call this tether assembler. Tether assembler. And where was that? Okay. Check code. Okay. Recompile. No errors! Yes! So if we go into custom data, I can't see anything. So is it not writing the custom data? So, I think what we'll do is we'll set up this button panel. Automated mining. And run with mode. So the way this is meant to work is you give it the command mode and then the mode you want it to switch it to. So, mode drilling. And if I have a look at the code for a second. There's mode drilling. And the command is mode. Yes, so that should be correct. Confirm. And then mode retracting, connecting. Let's just put this one back to start. We'll see. Okay, if I go here, F, we're not going down, so what's wrong? So I'm a bit disappointed this hasn't run. So I'll have a bit of a fiddle around with this script and I'll be back once I've got it fully functional. For the first part, that is. Oh, it's already going back up. I think I know what might be going on. Maybe getting a little amount of rock in one of them and then deciding it's full. But it didn't connect. Mode retracting. So I added this little echo to see what the current mode was. We can also add some echoes into the modes themselves to see what the current situation is. So, retracting didn't connect. Run it. Filled is false. We're drilling. Let's see what happens. We'll just watch this. See if this flips to true. It filled. It thinks it's filled. It's connectable, but it's not connecting. Interesting. Oops. I missed all of that in the actual recording, didn't I? Anyway, so what you just missed was, let's see, where are we? Yeah, we saw it was false until it got a little bit lower, and then that went flip to true. So there's a problem with my filled logic. Oh, that's on the wrong one. So we're not currently... It's not going to be 2.5, is it? I think it's going to be 5.0, isn't it? Yeah, 2 blocks down. Because we're making room for it, then we'd... Yeah, okay. My bad. Okay, so 2 errors there. 1 right there, and this was on the wrong one. So filled is meant to mean we're filled with stone. Okay, let's see how this does. So when we go down here, we weren't check connection allowed. Let's, rather than that, we will use the connector connectable in order to fire off this connection. And let's see what happens. Run drilling. So, right, this is what I was checking last time. We're in mode drilling. We're filled false, so we should be going down. And I have a feeling this isn't going to do anything for quite a while, because we're just slowly going down. So how about we come in here and speed this up a bit. Yeah, this is more like it. We might have an actual drilling operation, so let's have a check of this. Yeah, and it's getting nowhere near full. So we're still in drilling? Okay, I think it's actually... It might actually be working! Yeah! And I've sped it up quite a bit. So the only problem is the config isn't going through. I didn't realize you couldn't modify the... What's it called? Custom data field. Oh, that's what I put in. So what I believe I'm going to have to do is I'm going to have to put this onto one of the LCDs, probably this one. No content, text and images, edit text, yes. So I should be able to print out the config on there, and then I can manually copy it over and then edit it properly. So let's do that while we are currently back to the code. So how do we do that? I think we want to do that just after. How do we get the LCD? I think it's me dot surface. Right, I remember I did this as a bit of a testing thing before. I think we can just put 0 in, that'll be fine. And then text, write text. And then our value is this config string. And we can put the config straight onto the display. We can get rid of this, and I'll put the comment as display config. Now let's deploy that. Go back to the game. Edit the code, browse the scripts, in-game scripts, okay, run. And... That's why it wasn't displaying anything, because it's not changing anything. I suppose that makes sense. Yes, okay. I know I've done wrong. Silly sausage. Let's go back to the script. And we've got to set all of these. And what we'll simply do is we've got to save all of these values. What we're going to do is set config setup drill piston to and then we can just do it. Drill piston speed should do it. Does that work? Right. So it's not a setter anymore, a getter I mean. And there we go. This is all I have to do. So I will be back after I've done this a million times. And that should properly save it this time. So we're saving it. We no longer need that comment. It's self-explanatory. This I need to add in manually anyway. We'll get to that in a bit. So let's deploy and go back to the game. There we go. So edit, browse scripts. Okay, run. And custom data, yay! I can now edit these and we get what we want. So let's have a little bit of an experiment. We go into the custom data, set that to 1, 0.1 I mean, and then rather than run we need to recompile. That should make it a bit faster. And we can check in here. Its current speed is 0.1. Can I go faster than that? Custom data 5. This is stretching it. Recompile. And I think it can actually go quite fast. I'm just being way too scaredy cat. Yeah, let's just go full 1. Full bore. Okay, recompile. Now we're getting some activity. We have forgotten to set this higher. There we go. 1 might be way too fast. Yeah, way too fast.
Fuel low.
Okay, recompile.
Fuel critical.
Oh. I've really done it now. Fudge nuggets. Yay! Okay, that worked nicely. There we go. Had to press the retract button and it worked a charm. But we need to make retract stop the drills and everything. That would be a nice little touch. So we connected. And we're currently in mode unmerged. Anyway, I think that is a nice start to scripting, and I'm afraid I think I might have to leave it there, just as dawn is breaking. I think that's all we've got time for today, so thank you for watching. Typical. So, thank you for watching, and I hope to see you next time. Goodbye.